do men score lower on average compared to women on their statistics finals? In my experience, I think I've told this before, that does happen. It seems like the women always do better. Final exam scores. I'm not saying that to discourage the men. I hope men do really well. I'm happy for the women, but I just tell them it as I've seen it. Final exam scores of 11 randomly selected male statistics students and 12 randomly selected female statistics students are shown below. Okay, so here's a bunch of men and how they did on their statistics finals. Some did terrible, 57. Some did very well, 87, even a 90. Now here's the women and how they did on their statistics. Does it look like the women did better? Kind of does, doesn't it? We got a 97 and a 99 and a 90. And I don't see any 50s. Looks like in this group, the women did better. We'll see, though. Assume both follow a normal distribution. What can be concluded at the alpha point 10 level of significance? Level of significance. Oh, they said it twice. They repeated themselves. Level of significance, level of significance. Anyway, all right. So what kind of a study is this one? Let's go to the notes. So if we look at the notes here, we say, all right. Is it proportions? No, there's no proportions. Is there? I don't see any percentages anywhere. Do you? There's no percentages. It's not proportions. Is it two independent means or is it matched pairs? Now, it might look like matched pairs at first, but it's not. It's actually independent means. So let me help you see that. This can be tricky. This is where you have to really understand the words in order to see what I'm talking about. How do we know? Because you might say, you think, oh, Mr. Heritage, they're just matched up. They're just pairs. Well, visually, it might look like they're matched up. But there's two things that should help you notice that they're not. Mainly, it's the words. Just read about the words. Matched pairs, back here again, matched pairs means exactly that. They got to be in a pair, right? Meaning what? Like, and I give examples. I say actor, actress, a couple, husband, wife, brother, sister, or it might be the same person before and after some kind of treatment, right? Do they do better on the test before the tutor session or after the tutor session or, whatever? That's matched pairs. It's got to be matched up by something that's connecting them, matching them. Is that what we have here? Not at all. Not at all. This is not a husband and wife or a brother and a sister, right? No, there's no connection between them. Why not? Well, let's read the words. It just says final exam scores of 11 randomly selected males and 12 randomly selected females. So they're just two totally separate, independent groups. Two independent groups, right? There's no connection. They didn't say, we grabbed brothers and sisters who took statistics, and this is the brother and the sister, the brother and no, that would be matched pairs. That's not what we're doing here. These are just two independent groups. The other thing that makes it really clear is there's not the same number. There's 11 of the men and there's 12, right? There's 11 men and there's 12 women. So they're not even the same number. So how could they be matched up? So it's not matched pairs. It's two independent groups. So we go, oh, okay. So it's two independent groups. So we're going to do a two-sample t-test. That HO is mu1 equals mu2. H1 is mu1 greater, less, or not equal to mu2. Let's do it. So down here again, we've got to choose t-test. How's it go? It says t-test for the difference. I'll write it out. Difference between two independent independent population means. That's what we selected. This is going to be mu1, mu2 equals, HO is always equals. We're used to that now. This is mu1, mu2. What's this one going to be? Is this one going to be greater, less, or not equal for mine?
Less than.
Yeah. Good. You guys are getting used to picking these out, huh? It's right there. Lower, less. Min is mu1, women is mu2, just because that's the order in which they come in the problem. Min numbers are listed first, then women. So men are lower, men are less. So they're asking, do the men get a lower score on the final than the women in the statistics class? Okay, so there it is. If they had said higher, it would be greater. If they'd say different, that would be not equal, right? Or same or different, then that'd be equal, not equal. They say more or less, then we do greater or less. All right, let's go to it. To sample t-test. And then when they choose data. Oh, yeah, first we have data, don't we? So I forgot, we got to put that in our calculator, don't we? So step number 1, put male data down L1. The female data down L2. So go to your calculator, put these numbers down L1, these numbers down L2 on your calculator. So you know all about that. You've done that a lot of times. All right. So once you got those in, then you go on over to the 2 sample t-test. And you choose data this time, don't you? Choose data, not stats, data, and hit enter. And then it will say, what will it say? It'll say list 1, L1, list 2, L2, frequency 1, frequency 2, we'll put 1 and 1. And then the last thing is, the greater or less, not equal. So I'm going to choose less. That comes from right here. Less option for mine anyway. And the pooled is always no. And then we hit enter and crank it out. And okay, so I'm getting a test statistic, T equals negative 1.019 to 3 places and a p-value 0.1604 to 4 decimal places. All right, and so our p-value, which is 0.1604, that back in 1604. How does that compare to our alpha level? That's always the key thing. Here's the alpha level. Alpha is 0.10. Our p-value is what? Greater, isn't it? 16 is greater than 10, clearly. P-value is greater. What does that mean? So the most important phrase in the class, really the most important words in the class, if the P is low, the HO must go away, right? I hope those are making sense for you. If the P is low, the null must go away. Is my P low? You might get a different result, but is my P low? My P is greater, huh? So my P, so if it's greater, that means it's not low and the HO must not go away, right? So if the P is low, HO must go away. If the P is not low, then the HO must not. If P is not low, then the HO must not go away, meaning we're going to keep HO. It's not going to go away. So we go up here. HO, remember, is always weak evidence because you assume it. Like in a court of law, you assume the accused is innocent. And if evidence is weak, you keep that assumption. And the opposite, H1, you only conclude H1 if evidence is strong. So we are going to keep the assumption HO. We're not going with H1. The evidence is not strong enough to go with H1. We're going to keep HO, right? Keep HO. The P is not low, therefore HO must not go away. Keep HO. So we keep so the evidence is weak. We're not really convinced for sure that HO is true. It's just what we assumed in the beginning, like a court of law, when you assume the accused is innocent and the evidence is just not strong enough to convince you that they're guilty beyond a reasonable doubt. There's too much chance of doubt because the evidence isn't strong enough. So we stick with the assumption that because evidence is weak, we stick with equals. Notice what our conclusion is here. Equals. So we're saying group 1 and group 2, the men and the women are equal, really. We're saying the men and the women do about the same on the final. Equals means same, doesn't it? Now, we're not 100% sure they do the same. We just assumed they did the same unless evidence was strong. Evidence wasn't strong enough. It was weak. Why? Because there was a 16% chance of luck. If you look at these numbers, the female numbers did come out higher than the male numbers. But the problem is that's just not many people. It's only 11 men and 12 women. That could have been just a lucky group of 11 men and 12 women, where those women just happen to do better. If they'd taken a bigger sample, if they'd taken like 30 men and 30 women, then maybe that would have been strong enough evidence to where there was not a really low chance of luck if you take a bigger sample. But they had a small sample, only 11 men and 12 women. So the chance of luck, there was a 16% chance that we just happened to get a lucky sample. That's too big a chance of luck. That's more than 10%, which was the level they wanted us to test at. They wanted less than a 10% chance of luck. That was the alpha level. We got a 16% chance of luck, too high of a chance of luck. So we're going with HO. So that's insignificant, isn't it? Insignificant. The evidence is not significant enough. So insignificant, right? Not significant, not so. Yeah, it's one of those two, insignificant. So let's see. So there is insufficient. Yeah, there's not enough evidence to conclude that the population means for men is less than women. Yeah, that's true. There's not enough. You understand that phrase is correct. There's insufficient. There's not enough. Insufficient. There's not enough evidence to conclude that men are lower than women. There's not enough evidence to conclude that. Whereas this one says insignificant, then says there's significant. No, that's wrong. So there we go. There's our conclusion.